Okay, today we're going to be continuing our discussion of changes that can be made to the parent function. And today's topic, as the title screen suggests there, is going to be on phase shifts. Now, as you've probably already figured out, we've had all kinds of technological problems. For those of you that have been consistently providing me with feedback and letting me know whether things are working or not, I greatly appreciate your assistance as well as your patience. And you've probably already figured out that until I can sort out what the real problem is, I'm going to kind of get around the problem by continuing to post two different versions of the video, one that will link to YouTube for those of you that have had no trouble with YouTube at all and your devices are playing it quickly and seamlessly. And then I will also post a second video that will redirect inside of Edmodo for those of you that have had all kinds of trouble with the YouTube video. Just be advised that on the Edmodo video, you will have to wait for the information, the data to download. It doesn't actually download, it just kind of loads into your phone, plays the video, and then as soon as the video is complete, the information is gone. So let's begin. Today's objective, the student will discover the effects of a phase or horizontal shift upon parent functions and their equations. This video is for Tuesday, September the 17th. And be advised there, as you see, it says phase or horizontal. Horizontal is more of a description as opposed to a name. When you hear these shifts referred to, 9 times out of 10, they are going to be called phase shifts, not horizontal. So I will refer to them as phase shifts for the duration of the lesson. Okay, today we will continue looking at changes that can be made to the parent functions and see what effects they have on the graphs. And as we've already said, the next change we will focus on is the phase shift. Okay, here's your definition. A phase shift or a horizontal shift simply moves the location of the graph left or right. Now, in an equation, a phase shift is found by looking for a constant that is being added or subtracted directly to or from the independent variable. This is different from what we were looking at yesterday on vertical shifts, because a vertical shift could had a constant that was being added or subtracted really anywhere to or from the expression on the other side of the equal sign from the y value. Okay, this is more specific. This is what will happen when you add or subtract directly to the x value. Okay, now it can look different for different types of equations. Here's just a basic generic explanation. Y, or f of x, equals, and then you have a constant added or subtracted specifically to x. Now, how do you tell the difference between a phase shift or a vertical shift? Well, a phase shift is going to have to do something to the equation to specify to you that it is only affecting the independent variable x. Now, as I told you yesterday, the vertical shift, the one that we started off with, was the vertical shift, and we started with it because it was the easiest to read and the easiest to understand. That continues to be true. Very easy to spot it, very easy to read it, very easy to understand it. The phase shift is a little bit more difficult. It's not that hard to spot it in the equation, but it's a little bit more difficult to understand exactly what the phase shift is going to do. And I'll show you what I mean by that here on the next screen. Okay, so let's look at some of the changes to the parent functions that we have already discussed. Now, taking a quick glance at these three functions, I hope that you can very quickly identify what type of a function this is. These are quadratic. These will graph parabolas. You've got the parent quadratic over on the left-hand side. It has no changes being made to the equation whatsoever. The one in the middle and the one on the right, however, obviously have a change that is being made. These are both phase shifts because we have values added or subtracted specifically to the independent value x. Now, here are the graphs that go along with them. Okay, so as you copy them down, I'd like you to hit the pause button and look at the graphs and compare them to the equations and see if you notice anything that might be unusual or unexpected about the way that the graphs are showing up compared to the way that the equations are written. Hopefully what you noticed is that the phase shift went in the opposite direction that the equation might have suggested. Okay, the kind of written explanation here, obviously the parent function on the left passes through the origin. That's exactly what it's supposed to do. The one in the middle has been shifted leftward 2 units, and the one on the right has been shifted rightward 2 units. But look at the equations. The equation said x plus 2, positive 2. Okay, but the graph went toward the negative x-axis. On the right side, okay, the graph is moved to the right 2 units, but the equation shows negative 2 on the phase shift, which would have suggested should have gone to the left 2 units. And this is not a mistake in my notes or anything like that. That is the way the phase shift is going to work always. The sign of the constant is going to tell us the opposite direction of the shift. Okay, so positive phase shift means the graph actually moves leftward towards the negative x-axis. And while a negative value for your phase shift is going to move the graph rightward, which is toward the positive x-axis. So in a sense, the graph, when it comes down to a phase shift, is going to go the opposite direction of the way that your brain might be telling you that it should go. That's simply the way it works. I'll show you why that is here in a couple of days, but for right now, just understand phase shifts are going to go the opposite direction that the sign of the phase shift is telling them to go. The same rule is going to be true for all functions that we encounter, obviously the ones that we have already discussed, and any function that you can possibly imagine. So let's look at the ones that we have here. The graph on the left is clearly an absolute value function, very easy to tell. Okay, but the absolute value function is supposed to cross through the origin. Clearly it does not. It is missing it 2 units to the right. So that's a phase shift. Okay, so what should we expect from the equation? We should expect a phase shift, a value attached directly to x, but it should be the opposite sign. Instead of going towards the positive positive x-axis 2 units, we should expect a negative phase shift, so a negative 2. How about the one in the middle? What type of a function is that one? That's your square root function. Once again, where is the square root function supposed to cross? What is it supposed to pass through? It is also supposed to pass through the origin, but it clearly does not. It is missing it 2 units to the left. So that's a phase shift. So what value should we expect on the phase shift? Positive 2, because the phase shift goes in the opposite direction. The value of the equation is in the opposite direction of the graph that we can see in front of us. How about the one on the right? What type of a function is that? Clearly you can see that that is a cubic function. So where is the cubic function supposed to cross? What is it supposed to go through? Well, just like the other two, this one is supposed to go through the origin. Does it go through the origin? Clearly not. It's missing it 1 unit to the left. So what should you expect from the phase shift? Should expect a positive 1. And there you can see the equations. Absolute value function with a minus 2 phase shift, that will move it positively 2 units. Square root function, okay, the graph shows a negative 2 phase shift, but the equation should be the opposite, positive 2. And the one on the right, we have a cubic function, okay, and the equation shows a positive 1 on the phase shift, but that moves in the opposite direction, negative 1. How about these two graphs? Okay, what kind of a function are we looking at on the left, lower left graph? That one is logarithmic. Okay, so what or where is the logarithmic graph supposed to pass through? Logarithmic graph is supposed to cross the x-axis at positive 1. Obviously, this one is not doing that, so it has had a phase shift of some kind, and it has been moved towards the negative axis, so we should expect a positive phase shift. Now with the logarithmic graph, it's harder for us to know how much it's been shifted until we get either a better grasp of the logarithmic functions, or we have an XY chart where we can start comparing points to where they should have been with the parent function. Okay, how about the one on the lower right-hand side? What type of a function is that? That one is exponential. So what or where is the exponential function supposed to cross? Exponential should cross the y-axis at +1. Obviously it does not. This graph has had more time to rise up, so it is missing the y-axis where we expected. So that means that we have a phase shift, and again it's been moved towards the negative x-axis. That'll be a positive phase shift value. And again, until we get a better understanding of the exponential graph, we won't really know how much value to assign to that phase shift, but we'll get it as we go. So again, the logarithmic, okay, we have a +1 value for the phase shift because it has been moved -1. And on the exponential, we have a -2 phase shift value. That is incorrect. I need to correct my notes. We should have a +2 on the phase shift value because it has been moved negatively. So I apologize for the error in my notes. I should have caught that. Okay, we'll also reverse the procedure for reading the equations and then understanding what is going to happen to the graph. So let's look at the upper left-hand equation there. Okay, what type of a function is this? This is exponential. We should expect the graph to come along the x-axis in the second quadrant, cross the y-axis, and then bend into the first quadrant and head off to positive infinity on the y-axis. However, this graph has a phase shift. There's a value directly attached to the independent variable x, and it shows to be negative, which means the graph should be shifted positively. So this graph may be a little bit lower crossing the y-axis than we expect. We'll take a look at it here in a moment. What's happening on the second equation there in the middle? Clearly, it's logarithmic. Logarithmic graphs are the ones that come up through the fourth quadrant, cross the positive x-axis, and then turn more horizontal in the first quadrant. But we have a phase shift. Our graph has a +3 phase shift, which means it has been moved 3 whole units to the left. Okay, so we should expect, instead of it crossing the x-axis at +1, we should expect it to cross the x-axis at -2. That would be 3 units. The right-hand equation, clearly absolute value. Our absolute value function should be in quadrants 1 and 2. It should connect at the origin and kind of bounce off of the x-axis. But again, we have that phase shift right there, +1, which should mean our absolute value function has been moved negatively 1 unit. Let's take a look at the graphs. Okay, that is pretty much exactly what we just said. Those are the graphs. The remaining functions we have, clearly the lower left one is an absolute value, or not an absolute value, a square root function. Okay, and we expect our square root function to come out of the origin heading vertically, but turn very quickly to become horizontal, and that will all be in quadrant 1. But because of the phase shift, let's see what we have. Okay, we got a -2 phase shift. That'll mean it'll move positively on the x-axis 2 units. Okay, so instead of coming out of the origin, we believe it'll come out of 2, 0, and then behave like the square root function should. And on the final equation that we have there, clearly it is cubic. A cubic function should come up from -infinity in the third quadrant, turn through the origin into quadrant 1, and then turn upwards off to positive infinity on the y-axis. But we have a phase shift, so we have a +1 phase shift value. That means that the graph will be moved -1 unit on the x-axis. So instead of coming through the origin, it should come up through -1 on the x-axis. Let's take a look. And there are the graphs that we were expecting. Okay, that's where we're at this point. You've now added phase shifts to vertical shifts, and we will eventually start seeing them in the equations together as we go forward, having graphs having both vertical shifts and phase shifts. But for right now, just work on the phase shifts, and I appreciate you tuning in to take your notes. And again, I do appreciate all the people that have been very patiently waiting for me to get the technological issues straightened out. It has not been fun. I've spent a lot of time over the weekend working on this to keep us on track. So I hope it's working out. If you have any trouble, please give me some feedback so I can begin working on whatever else may be wrong with the videos.